Okay, so today we're going to look at the distance formula, and this is going to involve some simplifying of radicals, linking to our first video lesson. So when I look at this segment on the graph, so first of all, we haven't quite gotten to labeling yet, but I can call this segment AB. Okay. So we can call this segment AB. Or I could call it segment AB like that. So in some of the practice problems, you may see like find the distance of segment AB or find the distance of AB. Now, when I look at segment AB, it's on a diagonal across the graph. So I can't just count units as I could if I had a segment that was lying flat on the crosshairs of the graph. Well, then I could just count that it's 1, 2, 3 units long. But because this segment AB is slanted, I can't count exactly what the length or the distance from A to B is. So I have a couple of options on how we could find the distance between the 2 points. Using something that we've used before in Algebra 1 class, one option is to use the Pythagorean theorem. Okay, so this is one choice that I could have. So given this graph, I could use the Pythagorean theorem by creating a right triangle. Okay, so I could take this slant and I could draw a vertical down and a horizontal over. And because those are lying flat on the graph, I could find the distance of the legs of this right triangle that I just drew in. So this right triangle, this leg is 3 units. So 1, 2, 3 units over. The other leg is 1, 2, 3, 4 units up. Okay, and so I could look at that right triangle and use the Pythagorean theorem, which we talked about on our last video, a squared plus b squared equals c squared, where this slant AB is my unknown length. So I could call that length x. And so one leg a squared, other leg b squared is equal to that unknown hypotenuse squared. 4 squared plus 3 squared equals x squared. 4 squared is going to give me 16. 3 squared is going to give me 9. And adding that together gives me 25 equals x squared. And then to get x by itself, we would want to take the square root of both sides. And for this example, it's a perfect square. So the square root of 25 is just going to be 5. And last video we talked about those are inverse operations. So when I take the square root of x squared, it's just going to leave me with x. Or flip that around, x equals 5. That means that from A to B is 5 units long. So it would be the same distance if I were to take a ruler and measure that as it would be to go 5 units along the graph if I were to draw something in horizontally 5 units long. Okay, so my legs were 3 and 4 and my hypotenuse was 5, or the length of AB is 5, or the distance from A to B is 5. Now, we don't always have a diagram, so we're not always going to have a visual and then draw a right triangle and use the Pythagorean theorem. There's actually a formula that we can memorize that allows us to find the distance between any 2 points. So our other option here is to use what's called the distance formula. Now, our distance formula kind of looks intimidating when we first write it down, but it's really just substituting in numbers and simplifying it down. So our distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And so when we're doing our distance formula, we're really not so much thinking about the visual, although sometimes we have the visual to work from, but instead we're thinking about these ordered pairs. Where is point A and where is point B? And then what's the distance between those two? So when I look at point A, I could write down that A is at 1, 2. Point A is at 1, 2. Point B is at 4, -2. And so what you may remember when we do slope in Algebra 1, we label our points x1, y1, and x2, y2. So same idea here when we look at our distance formula. We have point A, an x and a y value, and point B, an x and a y value. And we're just substituting in to the distance formula those values. So x2 minus x1. x2 is 4 minus x1 is 1. Okay, 4 minus 1 squared plus y2, which is -2, minus y1, which is 2 squared. Now, when we're using the distance formula, we want to be careful about positives and negatives. Okay, just like with slope, I can end up with like a minus, a negative, and then that's going to make it a positive. Another thing we want to be careful of here is order of operations. So we don't want to forget about PEMDAS. Okay, order of operations. So when I'm simplifying this distance formula, first I'll start with the parentheses. So 4 subtract 1 is going to give me 3 squared, plus parentheses here is going to give me -4 squared. Next, I'm going to want to deal with exponents. So 3 squared is going to give me 9, plus -4 squared. Anytime I square a negative, it's going to make it positive. So -4 times -4 is going to give me positive 16. And then 9 plus 16 gives me 25. Okay, so I did parentheses, and I did exponent, and then I did that addition, and now I'm going to simplify this. The square root of 25, perfect square, is 5. Okay, so same answer that I got using the Pythagorean theorem. Okay, from A to B is 5 units long. Over here I use the Pythagorean theorem, and here I use the distance formula. The distance formula is going to be something we are going to want to memorize before we take our first quiz. That's going to involve distance and slope and simplifying radicals. So our distance formula, rewriting it here, distance is equal to the difference of our x values, or x2 minus x1 squared, plus the difference of our y values squared, or y2 minus y1 squared. One thing that helps me to remember the distance formula in terms of the signs here, because we're going to want to have this memorized, is I remember SAS, to remember that I subtract, add, and then subtract. Okay, and then I have to remember all the other pieces, but that at least helps me with the signs inside of there. So looking at one more example together, it says find the distance between -4, 2 and 2, -1. So when I look at this diagram matches those points. So it's saying here's -4, 2, so that's point A, and here is 2, -1, that's point B. And what is the distance from A to B? And again, it's this diagonal slant, and so I can't just count the units. I need to have some way to figure out that length or that distance. Our distance formula tells us that we can take the square root of x2 minus x1 squared plus y2 minus y1 squared. And so substituting in x2 minus x1. Okay, so our x values 2 minus -4 squared. So just like with slope, sometimes we end up with minus and negative. So if I go x2 minus x1, then I have 2 minus -4. Plus y2, so here's my y2 is -1 minus y1, which is 2 squared. Distance equals the square root of, again, following order of operations. So parentheses first makes this 6 squared plus parentheses over here gives me negative 3 squared. Now doing our exponent, 6 squared is 36. Squaring a negative is always going to make it positive. It's going to be negative 3 times negative 3, which gives me 9. 36 plus 9 is 45. So unlike up above, here in our first example, right, it was a perfect square. So, okay, our distance is 5. In this example, it's not a perfect square. It says the distance is the square root of 45. What we don't want to do is type that into a calculator and get like the decimal version of the square root of 45. Instead, we want to simplify this radical. So that's why we started by refreshing our memory on how we simplify radicals. So when I look at the square root of 45, I know that I can break 45 into 9 times 5. The reason I'm choosing to break 45 into 9 times 5 is because 9 is a perfect square. Square root of 9 is 3. And I can simplify that radical down to say, well, the distance from point A to point B, or from this point to that point, is 3 rad 5. And that's how I'm going to leave my answer as a simplified radical here.